All right, welcome everyone to another math video for all you rock stars out there. And this time we are focusing on, that's right, integers. You know, integers makes me think about cows and farms for some reason. And how does a farmer count his cattle? Well, it's pretty simple. He uses his calculator. Let's go. All right, today we're going to focus on integers, and this is all the standard-based jargon that teachers use to understand integers. But what are you going to do? You are going to understand what an integer is and how to represent it. And you're also going to know how integers work in the real world. That's our goal. We'll try to do that real quickly, get you an understanding so you can move on to some more advanced use of integers. All right, so before we get going, let's go ahead and talk vocabulary. What is an integer? What is this word you keep saying? Well, an integer is basically, if you think about at the very beginning when you first started learning to count, at the youngest age, your parents would put a couple things in front of you. You might count them 1, 2, 1 apple, 2 apples, whatever it might be. So counting numbers are just whole numbers, 1, 2, 3, 4, and 5. And then also let's go ahead and include 0. So 0, 1, 2, 3, 4, and then as far as you can count. And then let's also include their opposites, which is their negatives. So -1, -2, -3, -4. That's what integers are. And we're going to use a number line a lot. And when you're dealing with integers, it's a real valuable tool. I just want to make sure you guys understand them and have a little understanding about what these two type of number lines in particular can do for you. Because once we get past a basic understanding of integers, eventually we're going to be adding them and subtracting them. And we want to make sure we know how to do that using a number line. So real quick, these are two number lines that we're looking at right here. And one of them goes side to side, okay? And the other one goes up and down. Now, the side to side one, I want you to just think about, you know, like when you're counting numbers. So if you go to 0, this is the middle of our number line, if you will. Right there is the middle of our number line. And when we're counting, we are going to go ahead and say that we are going to count to the right to go positive. When we're getting numbers bigger, we are going to the right. So we can go from 0 to 1, and from 1 to 2, and from 2 to 3, and from 3 to 4. When you go this way, you are getting bigger. And then we can do the opposite. When we go this direction, we could say we're at -3 and we lose another $1. So now we've lost $4, and we've lost $5, and we've lost $6 because we're losing money and we're going left. Okay? And so when we understand that, we can start thinking about the positive and negative use of numbers and how they interact with each other. But now let's go ahead and look at this other one over here when it's going up and down, okay? And so when you look up and down, we still got the 0 right here in the middle. And I want you to think about that being kind of the ocean or the sea, okay? And this is just one way you can think about positive and negative numbers. So down here, we have a beautiful fish. Look at this drawing. Look at that fish. All right, and he's swimming down here under sea, and he's about that far down. And so if we look at that, we can see that we are at -5. He is swimming 5, let's say feet, 5 feet below sea level or below 0. Okay, and then if an airplane was flying overhead, and this one would be flying real low, let's say it was flying right through there, it's almost 3 feet above sea level, okay? And since we're dealing with integers, let's not say almost 3 feet. Let's say it's exactly 3 feet because it wouldn't be a decimal. It wouldn't be a fraction. It would be exactly 3 feet, okay? And that's as good as I can draw it on this. So you also can think about things like, you know, temperature, positive and negative. It's when you've said things like, oh, it's so cold outside. It's like 16 below 0. So again, here's 0 in the middle. And then we want to say 16 would be quite a bit below that. So 16 would be going below, which means we're going negative numbers. And if it's a real hot day, it might be 103 degrees. Well, then that would be taking us above 0, and we'd be heading up toward that positive number. Okay, so these are number lines. Hope that's just a quick introduction or just a reminder for most of us on how we use number lines. Okay, so let's put this to work. First of all, I want you to look at this number line and see if you see anything different compared to what we did it before. And I'll go ahead and tell you that The difference is this time we're not counting by 1. We're counting by 2s on this one. And they will make number lines counting by 2. We're even going -2, -4, -6, -8. Sometimes they'll make them count by 5s and sometimes by 10, sometimes by 100. It just depends on how big of numbers we're working with. Because if you were dealing with number in the thousands, could you imagine how big your number line would have to be if you were counting 1, 2, 3? So this one's counting by 2s. And our question says, what is the value of the orange dot if you move it 10 places to the left? Okay, so first of all, what is the value of the orange dot? Okay, if we look at this, our value of the orange dot is 6. And if we move it 10 places to the left, now this is where it gets tricky. If I go 10 to the left and I just start counting those hash marks, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But did I just move it 10 to the left? No. I moved it 10 spaces to the left, but each one of those spaces was worth 2. So I really went 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I really moved 20 to the left. So be careful. That's just a reminder to be careful when you're looking at number lines to see what the spacing is. Again, this one wants us to go 10 places to the left. So let's go 2, 4, 6, 8, 10. What is the new value of our dot? Well, it was at 6. It moved 10 to the left. Ended up right there, smack dab on the 4. So our value is -4. Now let's try another one. This one's a little different. Doesn't give us a number line. Gives us another pictorial representation. But this is kind of an intro. You're going to see a lot of this when you're dealing with adding and subtracting whole numbers and integers. Well, the key tells us that every red dot you see is worth -1. Every yellow dot you see is worth a +1. Well, they only give us red dots in this scenario. And the question is, what integer is represented in the illustration above? Well, let's look at that. So how many, we told us, first of all, we said that the red dots are each worth -1. And how many of those do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8. So if we have 8 dots and each one of them is -1, we have -1, -2, -3, -4, -5, -6, -7, and -8. So we have -8. Those red dots each represent -1, which means the value that represents, the integer, is -8. Okay, pretty simple right there, but it will get harder when we get into the adding and subtracting. Let's look at this number line going up and down. What do you think this one's measuring? There's a clue in the number line. Well, that C right there stands for Celsius, which is a way we measure temperature. In America, we use Fahrenheit, and a lot of other countries, they use Celsius. Well, all they want to know is where. Remember we said we're going to learn how to represent integers on a number line? Well, we want to know where 9 degrees below 0 would be. Well, there's 2 9s on our number line right now. We have a 9 here, and we have a -9 here. We have to figure out which one of those we're going to use. And there's a key word in this sentence that helps us. You guys know what that key word is? Well, it's below 0. This one's giving us a direction to go, below 0. So our 9 degrees below 0 would actually be -9, and it would be right there on our number line. Let's try this one on your own, and then we'll come back and see if you're right. The question is, identify each integer on the number line. In other words, what does the A represent? What does the C represent? What does the B represent? And what does the D represent? Go ahead and pause real quick and see if you can solve those. Okay, well, let's look at the A first. Well, remember we talked about our number line. We want to make sure we understand what these spaces actually represent. So in this situation, we have a 0 here, and we have a -5 here, and we have a 5 here. So how many lines or how many spaces do we have from 0 to 5? Well, we go 1, 2, 3, 4, 5. So in this situation, each one of these lines represents 1, an integer of 1. So the gap is 1, or we're going 1 each space the other direction. So let's start with A. Where is A? Well, here is A right here. And if this is -5, what would be the next one to the left? If each one of those spaces equals 1. Well, we started here, and we went -1, -2, -3, -4, -5, -6. So your A should have been -6. Where is B? Well, 1, 2, 3. Remember, I started at the 0 and counted, so B would have been 3. We can look at C and say it's just 1 to the left of 0. 1 to the left of 0. And if we're going to the left, we're going negative, right? So that would be 1 to the left is -1. And then finally at D. D is 2 to the right of 5. Well, here's 5. So that would be 6, and that would be 7. I think you guys are getting the hang of it. I think it's really good. Let's do one more scenario. Pause the video and go ahead and type in the answer to these, and then we'll come back and see what you got. Fish swimming 20 feet below sea level. 20 feet below. That's going to give us a -20. A cold winter day with a temperature of 37 degrees. Be careful, just because it says it's cold doesn't mean it's going to be a negative number, because 33 degrees is freezing in Fahrenheit. So that means our cold winter day, 37 degrees is still cold. So it doesn't say a negative or below 0 temperature. So this is just going to simply be 37. A person loses 13 pounds. Loses. Do you think that would be a positive or a negative? Well, that would be a negative because you're losing it. Taking away 13 pounds. Taking $32 out of the bank. It's kind of like the last question. We're taking something away. So we're taking away $32. Putting $72 into the bank. So now we're gaining money. We're earning money. That's good news. That's $72. And a temperature of 17 degrees below 0. Now there's that below 0 number or phrase, which tells us it's going to be -17. I think you guys are getting it. I think you're turning into absolute rock stars, which is great. So I think you guys are ready to move on to the task, move on to the next assignment, move on to whatever's after integers for you. Let's dig in. But before we do that, I just want to make sure you understand that integers cannot be fractions. They cannot be decimals. They are simply 1, 2, 3, 4, and -1, 2, 3, and 4, and both of those directions for as far infinity, if you will. All right. Going back to those cows and those farmers, it really had me thinking about something. So what do you get if a cow is in an earthquake? Now, if you said a milkshake, you would be right. Well done. You guys have a great one. We'll see you the next time we want to hang out and talk about math.